before we can balance neutralization reactions then, you need to know the formula for the acids. So there are three that you need to know: hydrochloric acid, nitric acid and sulphuric acid. So hopefully you'll remember that hydrochloric acid is HCl. You might not remember, but you need to, that nitric acid is HNO3 and sulphuric acid is H2SO4. Now in chemistry all of these acids are in solutions, which means they dissociate into ions. The state symbol for all of the acids is AQ, aqueous, and what I mean by dissociates is when you put these into solution they change into the separate ions. So in hydrochloric acid you have H plus Cl minus, nitric acid H plus and then NO3 1 minus, and in sulphuric acid you get two H plus ions and you get one SO4 2 minus ion. It's important to remember those and the ions they form. You also need to be able to remember the byproducts from neutralization reactions. So there are three ones you need to know. If you have a metal on its own, and in that case you get hydrogen, which is H2. If you have a metal carbonate, you have water, and you also have carbon dioxide, CO2, and a metal oxide or hydroxide gives you H2O, water. Now this is the same in every single neutralization reaction, so have a look out for what you get and that'll tell you your byproducts. Okay, let's start with a couple of examples. So this one here starts off with lithium. So lithium, you should know, is a metal and therefore it just goes around as Li. Reacts with hydrochloric acid, we've just been through, that's HCl, to form lithium chloride, and they've given you the formula of lithium chloride as LiCl, and a gas. Now because this is a metal on its own, we know that that gas is going to be hydrogen. Now straight away we've got 2 marks out of 3. What we need to do now is do the balancing to get our third mark. So we put in what we've got on the left and the right hand side, which is 1 lithium, 1 hydrogen and 1 chlorine on the left. And on the right I've got 1 lithium, 2 hydrogens and 1 chlorine. So what I need to do is choose something to balance. So I'm going to go with the hydrogen and I'm going to put a 2 in front here. That changes that to 2 hydrogens. My chlorine is not balanced though. So if I put a 2 in front of my lithium chloride on the right, that doubles that, which is balanced, but it also changes my lithium on the right as well. So all I need to do is put a 2 in front of my Li here, and I have my balance symbol equation and my third mark. Now that pattern continues with all of them. The only difficulty will be is if they actually make you work out the formula. Now this will only be for your A-star type question. So here we're given MgOH2, magnesium hydroxide, reacts with nitric acid, which is a neutralization reaction, and they ask you to write the balanced equation. So straight away you get 1 mark for putting in the reactants. Now to work out the products, what I'd always do is make sure you know the word equation. So magnesium hydroxide plus nitric acid gives you magnesium nitrate. If you can't remember how to do that, look back in the word equation videos. And then, because it's a hydroxide, I'm going to have water. So your next step is to work out the charges. OH minus is one you have to remember. Magnesium is Mg2 plus because it's in group 2, loses 2 electrons, becomes Mg2 plus. And I told you the ones for the acids earlier on. So we have Mg2 plus and NO3 minus. Rub out the charge, take that number and swap it down to there, and then because it's a compound ion I put it in brackets. So my formula for magnesium nitrate is MgNO3 2. Again, if you're not sure how I've done that, watch the Finding the Formula video on my website. As I said, we get water because it's a hydroxide, so I add H2O. So that's my first 2 marks. Let's move on to the balancing then. So I have 1 magnesium, 2 oxygens in my magnesium hydroxide and 3 in my nitric acid, so 5 in total. I've got 2 hydrogens in my magnesium hydroxide and 1 in my nitric acid with 3 in total, and then I've got 1 nitrogen. On the right hand side I have 1 magnesium again, I have 2 nitrogens, I have 2 times by 3, which is 6 oxygens, and then 1 extra in my water over here, so that gives me 7 in total, and then my hydrogens I just have the 2. So now when it comes to choosing something to balance, although magnesium nitrate is a big compound, everything in there is even. So let's have a look at my nitric acid and put a 2 in front of there and recount. So my hydrogen, I had 1, I've got 2, plus my 2 from my magnesium hydroxide gives me 4. I've got 2 nitrogens, and then I've doubled my oxygen, so I've got 6, plus my 2 from my magnesium hydroxide, that gives me 8. So this is very nearly done. Let's have a look at my hydrogen. I've got 4 on the left, 2 on the right, so let's double it. That gives me 4 hydrogens, which is balanced. It doubles my oxygen in my water molecule, so that added to my 6 that I already had gives me 8, and that's the only thing that's not balanced, which gives me my full third mark. Okay, one final example then. So this one says sodium carbonate Na2CO3 is neutralized with sulphuric acid. Sulphuric acid, you'll remember, is H2SO4. Now that one, again, write the word equation. So sodium carbonate and sulphuric acid is going to give you sodium sulfate, and because I've got a carbonate, that's going to give me carbon dioxide and water. So what I've got to do now is take this and turn it into my symbol equation. So I know I've got sodium sulfate. Sodium is Na plus because it's in group 1. Carbonate ions are the ones you need to remember, is CO3 2 minus. Sulphuric acid, I told you earlier in the video, is H plus and SO4 2 minus. So sodium sulfate then, I've got my sulfate and my sodium ion. So let's put these side by side like I'm doing here. The next job is, as I've said, rub out the charge on both sides and then take the number and swap them around, put them down below. So that gives me Na2SO4. So that can go in here up at the top, Na2SO4. All that's left is to put in the actual byproducts. We know carbon dioxide is CO2 and we know water is H2O. Okay, so on to balancing then. Sodiums, I've got 2, carbon, I've got 1, oxygen, I've got 3 in my sodium carbonate, I've also got 4 in my sulphuric acid, so that gives me 7 in total. Hydrogen, I've got 2, and sulfur, I've just got the 1. On the right hand side, I've got 2 sodiums, so they're already balanced. I've got 1 carbon. Oxygens, I've got 4 in my sodium sulfate, 2 in my carbon dioxide, and 1 in my oxygen. So that gives me 7, so that's balanced as well. Hydrogen, I've got 2, that's balanced as well. And finally, sulfur, I've got the 1. So everything there is balanced. I don't actually need to do any more. Okay, we've got 6 questions then I'd like you to have a go at. 3 are usually grade B to C, or in the new grading that's grade 4 up to 7, and then we've got the challenge ones which go up to your 9 or your A star, which are your proper challenge questions. So question 1 says sodium reacts with hydrochloric acid to form sodium chloride, NaCl, and hydrogen. Number 2, copper hydroxide, COOH2, reacts with nitric acid, HNO3, to form copper nitrate and water. And then number 3, solid calcium carbonate reacts with sulphuric acid to form calcium sulfate solution, water and carbon dioxide. For each of the 3, write the balanced equation, and then for the third question include state symbols. Questions 4, 5 and 6 are challenges, so you actually have to do it without being given the actual formulas for the reactants and the products. So have a go at doing questions 1 to 3. If you're feeling up to the challenge, go for 4, 5 and 6 as well. Pause the video now and have a go. Okay, let's go through question 1. So to start off then, we've got sodium. Now sodium is Na, goes around on its own because it's a metal, reacts with hydrochloric acid. Hydrochloric acid, you should remember, is HCl. It forms sodium chloride, which they've given you the formula of NaCl, and then hydrogen. You need to remember that's diatomic, so it goes around in pairs, so H2. That's 2 of your 3 marks already. Then you need to count up what you've got. So I've got 1 sodium, 1 hydrogen and 1 chlorine, and on the right I've got 1 sodium, 2 hydrogens and 1 chlorine. Choose one to balance. So we haven't got any particularly large compounds here. In this case I'm going to go with HCl because I've got 2 hydrogens on the right and only 1 on the left. So I'll put a 2 in front of there, and as you can see, that doubles my hydrogen and makes it balanced, but my chlorine is no longer balanced. So I need to go over to the right hand side, put a 2 in front of my chlorine. Obviously it's got to be in front of the whole compound. That doubles my sodium and doubles my chlorine. So I've now got to go over to my sodium over here. I've only got 1, I need 2, so put my second one in front there. That balances it and gives me my third mark. On to question 2 then. So I've got copper hydroxide, which it gives you in the question. Reacts with nitric acid, HNO3. So just from picking that information out of the question, I've got 1 mark. It forms copper nitrate, which gives you CuNO3 and water. So the only bit of memory there is you've got to remember that water is H2O. So that's 2 of the 3 marks again straight away. Your next job, count up. So I've got 1 copper, 2 plus 3, which is 5 oxygens, 2 plus 1, which gives me 3 hydrogens, and then 1 nitrogen. On the right hand side, I've got 1 copper, I've got 2 times 3, which is 6, plus my 1 over here for my oxygen, which is 7 in total. Hydrogen, I've just got the 2, and then nitrogen, I've got 1 inside the bracket, but I've doubled it, so I've got 2. As you can see, my copper's already balanced, so at the moment I don't need to do anything with that. The next job is to have a look at what is the biggest compound that is uneven, unbalanced. All of these are even, all of these are even. This one at the moment isn't, because I've got 3 oxygens. So let's have a go at doubling it and making it even. So if I put 2 in front of there, you can see my oxygen changes from 3 to 6, so I've got 8 in total. My hydrogen changes from 1 to 2, so I've got 4 in total, and my nitrogen also changes from 1 to 2 and is balanced. The next thing, I can either choose a hydrogen or oxygen because they're not balanced. It doesn't matter which one you go with. You know I've got 4 hydrogens over here, 2 from here, and now 2 from here. I've only got 2 on the right, so let's double that. By doing that, you can see that balances the oxygen as well, because I've got my 6 from here, plus 2 times 1 is 2. That gives me 8, and my hydrogens have doubled as well. So that's my balanced equation and my third mark. On to number 3. We've got solid calcium carbonate, which it tells us again is CaCO3, reacts with sulphuric acid, H2SO4, to form calcium sulfate solution, CaSO4, water, which is H2O, and carbon dioxide, which you've got to remember is CO2. Again, that's 2 of my 3 marks. Your next step is to counter what you've got. So I've got 1 calcium, I've got 1 carbon, I've got 3 oxygens, plus 4 over here, so I've got 7 in total. I've got 2 hydrogens, and I've got 1 sulfur. On the right hand side, I've got 1 calcium, so that's balanced. I've got 1 carbon, that's balanced. I've got 4 oxygens, plus 1 from my water, plus 2 from my oxygen, which gives me 7, which is balanced. I've got 2 hydrogens, also balanced, and then I've got 1 sulfur, balanced. So it's already balanced, so we don't need to do any balancing here. However, I have got including state symbols, and it gives you some clues in the question. So solid calcium carbonate, you put an S in, reacts with sulphuric acid. You need to remember all acids are aqueous. Calcium sulfate solution also means aqueous. Water, you should remember, is a liquid, so L, and carbon dioxide is a gas, and that gets you your third mark in this situation. That ends the normal questions. If you fancy going up to the top end challenging questions, move on to question 4, or skip to the end of this video and have a look at the review section. Okay, so you've stuck around for the challenge then. Let's have a look at it. So this is the neutralization reaction between aluminium and nitric acid. So aluminium is a metal, so it's on its own, an Al. Nitric acid, you just need to remember, is HNO3, and then we've got to work out the actual products and the byproducts. So first things first, let's have a look at the ions. Aluminium is in group 3. It loses 3 electrons, becomes Al3+. Your nitrate is one of the ones you need to learn, which is NO3 1-, and hydrogen is H+. Because we've got a metal on its own, if you remember the word equations for this, you should remember that when any metal on its own is reacted with an acid, you get hydrogen, and that hydrogen is diatomic. Your next step is you have aluminium and you have nitrate left over, so your actual product is aluminium nitrate. So what we do is we remove the charges, take this number here, it goes down below, and because I've got a compound ion, I can put it into brackets, just like that. So my formula for aluminium nitrate is AlNO3 in brackets 3. That's my second mark, and then my third mark is for balancing it. So I have 1 aluminium, 1 hydrogen, 1 nitrogen, and 3 oxygens on the left. On the right I have 1 aluminium, 2 hydrogens, 3 times by my 1 nitrogen, which is 3, and 3 times by my 3 oxygen, which is 9. So, as I've said to you in the past, the best bet is to usually take the big compound that's got an odd number in. So this has got an odd number in, but this has as well, and that's quite a big odd number, and it's the biggest compound. So let's start by doubling that. If I do that, as you can see down here, everything is doubled. Aluminium 2, nitrogen I've gone from 3 to 6, and oxygen I've gone from 9 to 18. Then go back over to the left hand side. Let's choose something. We've got an odd number of oxygen, we need to get it to 18, so let's go with this. What can I times 3 by to get 18? The answer is 6. As you can see, this affects the hydrogen, the nitrogen and the oxygen. I had 1 hydrogen, I've times it by 6, so I've got 6. I had 1 nitrogen, I've times it by 6, I've got 6, which is now balanced. And I had 3 oxygen times by 6, gives me 18, which is balanced. So the next task is to sort out either the aluminium or the hydrogen. Doesn't matter which. In this case I'll go with the hydrogen. I have 2, I need 6, so I times it by 3, and that's balanced. And then finally aluminium, I've got 1, I need 2, so I times it by 2, and that's my balanced equation, and that's my third mark. On to number 5 then. So this one, it says write the balanced equation for the neutralization reaction between sodium oxide and hydrochloric acid. Let's start by putting off the information we know. So we've got hydrochloric acid, which is HCl, and because I've got an oxide, again, think back to the word equations, sodium oxide plus hydrochloric acid, I'll get my salt, which I need to name, and I get water, H2O. The next thing to do is to figure out my formula for sodium oxide. Sodium's in group 1, loses 1 electron, becomes Na+. Oxygen's in group 6, gains 2 electrons, becomes O2-. I get rid of the charge, swap the number, and put it down below. It gives me the formula Na2O. And the right hand side, you take the name of the metal, you take the acid, so I get sodium chloride, Na+ and Cl-. The charges are already balanced, so I get rid of them, and my formula is NaCl. All that's left is to do my balancing. So I've got 2 sodiums, 1 oxygen, 1 hydrogen, and 1 chlorine on the left, 1 sodium, 1 oxygen, 2 hydrogens, and 1 chlorine on the right. So at the moment my oxygen and chlorine are balanced, but my hydrogen and sodium aren't. I'm going to start with hydrochloric acid, and I'm going to double that to make that even. By doing that, my hydrogen is even, but it's made my chlorine uneven. Now I need to sort out my sodium or my chlorine on the right. As you can see, they're both part of one compound, so if I put a 2 in front of there, it doubles both. My sodium's balanced, and so is my chlorine, and there's my third mark. First one, reactants, second one, products, the third one for your marking, your balancing. Okay, let's move on to the final one then, which is the trickiest one, which is the balanced equation for the neutralization reaction between solid ammonium carbonate and sulphuric acid. So, let's start off with the ions. Aluminium, group 3, loses 3 electrons, becomes Al3+. Carbonate, you've got to remember, is CO3 with the charge of 2-. So we do the same thing again, we get rid of the charges, and then we take the numbers, we swap them round, put them subscript, and because my carbonate is a compound ion, I put it in brackets. So my formula is Al2 in brackets CO3 3. I'm reacting it with sulphuric acid, you just need to remember that's H2SO4. And then on the right hand side we get aluminium reacting with sulphuric acid, so that gives me aluminium sulfate. Aluminium we've already discussed is Al3+. Sulphate you need to remember is SO4 with the charge of 2-. We do the same again, take the charges away, swap the numbers, put the compound ion in brackets, and that gives me the formula of Al2SO4 3 in brackets. All that's left is my byproducts. Now because I had a carbonate, I get water, and I also get carbon dioxide. So that's 2 of my 4 marks. Your next step is to count up what you've got. So I've got 2 aluminiums, 3 carbons, 3 times 3 is 9 oxygens, plus 4 here, so that gives me 13 in total, 2 hydrogens, and 1 sulphur. On the right hand side I've got 2 aluminiums, I've got 1 carbon, I've got 3 times 4 is 12 oxygen, plus 1 in my water, and 2 in my carbon dioxide, which gives me 15 in total. I've got 2 hydrogens, and I've got 3 sulphurs. Now this one is probably above anything you'll get at GCSE, but it's still not a bad skill to have to be able to balance it. So let's have a go. I can choose any one of my ones that's got an odd number in and balance it. So let's have a look at this one. I've got 9 oxygens here. That's looking like an awkward one. So let's start by balancing that. So if I double that, that doubles my aluminium, it doubles my oxygen, and it doubles my carbon. Now bearing in mind it's only doubling this one here, I haven't changed that there. So it's 18 because I had 9 times by 2, which is 18, plus my 4 from there is 22. So at the moment still nothing is balanced. So let's choose something else. I've got 3 sulphurs in here, which is an odd number. So let's have a go at that and see if that works anything else out. So 3 multiplied by 2, that will give me 2 times as many aluminium, so I'll have 4, 2 times as many sulphur, so I'll have 6, and 2 times as many oxygen, I had 12, so that will give me 24. Now here you can see the aluminium has become balanced, so let's leave that one for the time being. The next thing to look at is either carbon or sulphur. And I'm going to go with my sulphur on the left hand side because I've got 6 over here now, but I've only got 1 on the right. So what do I put in front of there to give me 6? That's 6. Now by doing that, I times my 2 hydrogen by 6 as well, so that will give me 12. My sulphur by 6, so that's 6 times 1, which is 6. And my oxygen, which is 6 times 4, so that changes to 24. As you can see here, which totals up my oxygen to 42. Hopefully you're staying with me with this one. Next thing I need to do, well, let's have a look on the right hand side. I can either go with the carbon there, or I can go with the water there. I'm going to go with the water, so I've got 2. If I put a 6 in front of it, that will times 6 by 2 to give me 12. It will also change the number of oxygen, because I had 1 in here, times that by 6, and ups that to 32. My hydrogen is now balanced. So the last one I need to look at is my carbon. I've got 1 on the right, 6 on the left, so I can put a 6 in front of there. And magically, if you count up now, everything becomes balanced. However, we're not finished there. The one thing you'll notice is all of these are even numbers and all of them can be divided down. So, if you get into this situation where you've got a 2, 6, 2, 6, 2 or 2, 4, 2, 4, if all of them are even and can be divided by 2 or by 3, then do it. So if I divide everything there by 2 and then check, aluminium I've got 2 and 2, carbon I've got 3 and 3, oxygen I've got 9 plus 3 times 4 is 12 is 21, and over here 3 times 4 is 12 plus 3 times 2 is 6, which is 21. Hydrogens, 3 times 2 is 6, 3 times 2 is 6, and sulphur, 3 times 1 is 3, 3 times 1 is 3. So that's balanced, and that is my 3rd mark. It's also asking for state symbols, so don't forget that. Aluminium carbonate, it tells you as a solid. Carbon dioxide, you know, is a gas. Water, you know, is a liquid. Aluminium sulphate, usually when you react any base with an acid, it becomes aqueous. All acids are aqueous, and as I said earlier, it tells you got your solid in the actual question, and that's your 4th mark. That's a tough one. If you didn't get it, don't worry too much about it. If you did, then you can have a go at the review question. So there are 6 here. I'm not going to read through all of them. What you need to do is read the questions and actually have a go at them. If you feel as though you are struggling, only concentrate on these 3, but if you want a challenge, go for the 3 down below as well. And that ends this video. Hi guys, I hope you enjoyed the video. If you did, click on the subscribe button down below, visit the website, and you can find me on Facebook and Twitter.